So now let's just compute a times x, and x is this x vector. And we're just going to do it the way we did it before. So I'm going to take, well, first I need to check, right? So this is 3 by 3. This is 3 by 1. These match up, so that's okay. So the first one's going to be x1 times 2, negative 1, 6. Second one's going to be x2 times 3, 5, negative 2. And then x3 times 4, negative 3, 8. And if I combine these together, what do I get? 2x1, negative x1, 6x1 for the first vector. 3x2, 5x2, negative 2x2 for the second one. 4x3, negative 3x3, 8x3 for the third one. And then when I add all these together, what do I get? 2x1 plus 3x2 plus 4x3. It's the first entry. Negative x1 plus 5x2 minus 3x3. The second one. 6x1 minus 2x2 plus 8x3 is the third one. So notice it's still just a 3 by 1 vector. Okay, it's 3 by 1 because with these addition signs, right, this is just one complete entry, right, one entry. And it's the left side of a system of equations, right, just like we talked about before. But I also want to point out something else. So this first entry here was just the first entry of this row times the first entry of the vector plus the third, or the 3, which is the second entry in this row, times the second entry in this column of the vector, plus 4, which is the third entry of this row, times the third entry in this vector. So if you think of the rows of A being vectors, called row vectors, then this should be familiar to you. If you've studied vectors in another class, this would be called a dot product. So let's talk about dot product. If you've got two vectors, and here I have vector u and vector v, if you take the dot product, what you do is you just multiply the corresponding entries together all the way down, and then you add them together. So here's the product of the first entries, and here's the product of the second entries, and you just keep going, and here's the product of the last entries, and then you add all those up, and that's called the dot product. Now dot product gives you, it takes two vectors and turns that product into a real number. Okay, these are not vectors anymore after you take the dot product, but that's a way to get this matrix vector multiplication. You can just take the dot product of this row and this column, and that's your first entry. And you do it again, the second row. Take the dot product of the second row with this column, you get the second entry, and you just keep going. So let's do a couple of examples of multiplying a matrix times a vector, and we use the dot product method instead of the linear combination method. So first we need to check to see if the dimensions match up. This is a 2 by 3 matrix. This is a 3 by 1 vector. So yes, the number of columns of the matrix matches the number of entries in the vector. And what we're going to get out is a 2 by 1 vector. So I'm going to give myself some room to do the dot products, but this is a 2 by 1 vector here. The first entry is the first row dot product with that vector. So you multiply the corresponding entries, so 1 times 4, and then you add them together, 2 times 3, and -1 times 7. So we simplify that, we'll just get one number, and that'll be the first entry of the vector. Second entry, second row of the matrix, dot product with the vector, and we're going to multiply the corresponding entries. 0 times 4, -5 times 3, and 3 times 7. And just to point out that this is still very, this is equivalent to what we did before. See, this is 4 times the vector 1, 0, right? Times that first column. And this is 3 times the second column, right? And 7 times the third column. So it's doing exactly the same thing that we did before. So let's just simplify this really quickly. 4 plus 6 minus 7, 0 minus 9 plus 21. No, minus 15. I read that wrong. Minus 15 plus 21. So we get 3, 6. That's the same answer we got before. So let's do the same thing with this one. This is a 3 by 2 times a 2 by 1. So that matches up, and we're going to get a 3 by 1. And we're going to go by row and column. First row of the matrix times the vector column. Dot product. 2 times 4 plus -3 times 7. Second column. 8 times 4. 0 times 7. And then the third column, -5 times 4 plus 2 times 7. And we'll just, you can see it's 3 by 1, right? So we just need to simplify this. So we get 8 minus 21, 32 plus 0, -20 plus 14. And that is -13, 32, and -6. So that should be the same thing we got before. So when you do this matrix vector multiplication, if you've got a matrix times the sum of two vectors, it distributes, and it's multiplication on the left. A matrix A times vector U, A on the left, U on the right, and A on the left, V on the right here. And if you have a constant scalar, you can factor that out. Okay, you can factor that out. You can do the matrix vector multiplication first and then multiply by the scalar after.